I am recording the session right now, so the session is being recorded. Just a reminder to maintain professional and respectful exchanges of questions and ideas. Whatever you say or do is being recorded with your name forever attached to it, so just be mindful of the audience. Okay. So let me share my screen. I'm going to share my overhead. So let me just put this back on here. Whoops. So this is, I'm going to sketch something here. So here's what we did. Whoops. Here's what we did last day. What we talked about. So we have a couple of colors. So we have an existing center line and a proposed center line. We're going to draw the edge of pavement in the subdivision. So there was a radius here coming around, then there's the bulge, and then there's the cul-de-sac, and then back down to the edge of pavement. So that's what you should have had done as part of assignment number number 2. Let me redraw that. I just realized I went off the screen. So the edge of pavement looks like this. And the center line goes all the way through and beyond to the right of way. Okay, so that's what we should have had as the center line proposed. This is the existing center line of the road. It's proposed center line, and the green line is what we're calling edge of pavement, which is to say the gutter line, the position of the gutter, okay, in green. So what we did was we determined, so I can do this in red, of these 2 points. Actually, we need the station value of the edge of asphalt on the existing road, right? So there's an existing edge of asphalt through here. Okay. We need that station value, so that's our first station elevation. Then of these 2 points, one of them is closer or away, closer to the subdivision or out from the away from the intersection. So if you drop a perpendicular for these 2 points here, it's the one furthest away, low point station. Just going to call that out here, low point. This is the existing edge of asphalt. Oops, asphalt. Okay, and then there's a point where the standard width of the pavement ends and then begins again. So that's the beginning of the knuckle. That's the end of the knuckle. And then we go all the way to the last time we have a standard 20. That's the end of the standard 20, right? So between here and here, typical 20-meter right-of-way. Between here and here, typical 20-meter right-of-way. And from here forward, we have the cul-de-sac. Between these 2 points, we have the crescent or the knuckle, the eyebrow, the elbow, whatever you want to call it. And we determined that in the standard 20-meter right-of-way, we want 0.5%, which is the typical minimum, 0.5%. Between here and here, I calculated, you have to check your own, I calculated 1.5%, right? I calculated the length along the gutter, right? This is the length of the gutter. If this is 1% minimum, what does the center line slope have to be between these 2 points? And then the same thing down here. The gutter from here all the way around to here had to be minimum 1% on both sides. It's actually symmetrical. So if that's 1%, what does the slope along the center line have to be? And I determined that to be 1.25. These numbers, 1.5, 1.25, you have to determine those values for yourself based on your geometry. You should practice that calculation we did together because you're going to have to do something similar next semester. And it's a standard calculation you would perform on any of these roads that require either a crescent, a cul-de-sac, or even at an intersection. You may have to deal with stuff like this. Okay, so it's always good practice. Remember what we do, I use the phrase the tail wagging the dog. I'm trying to design the center line, but I have to be mindful of what I have to achieve at the gutter. So I start with the gutter and I say, okay, if my gutter needs to be 1%, what does my center line have to be in order to guarantee that? right? So on my center line design, I'm thinking ahead a little bit. What's my gutter requirement? Okay. And usually these odd widenings, crescents and cul-de-sacs, they require steeper than typical, right? On a standard 20-meter right-of-way, you can get away with 0.5%. That's accepted. But when you have these longer gutter lines, they want a little bit more. Sometimes 1%. This is Town of Richmond Hill standard. Next semester, I believe the standard is 0.75%, always steeper than the minimum half. So based on that, then we go to our profile. So on our profile, what we do is in the plan view, we put points in the plan at these special locations. Right? So I identify the station values. And down at the end here, remember, not the gutter line, but 0.3 meters in. The last point on the asphalt is where that profile starts. Right? Remember this dimension here is 0.3, which is your distance from edge of asphalt to gutter. Okay. So once we draw those points in plan, we can use Civil 3D to project those points from the plan to the profile, and then we have our station values for our profile design. And that's all you get, station locations. Then you have to design the elevations for each of those stations by putting in the appropriate slope. And remember, we're going to go down to the low point, 0.5%. Then we're going to go positive 0.5%, then positive 1.5, positive 0.5, and then positive 1.25. Okay, and that was the profile design. This was the concept again, and I'm doing this on purpose with a sketch because this is the design. How you do this using Civil 3D, that's a process. Right? But understanding how to do the design and what the design is really what I'm trying to emphasize here. Okay, any questions about that? Wei, I'll have to check yours. Okay, there might be an error in reporting, so I'll look at yours again. Okay, send me an email, please. Okay, any questions about the design concept? Okay, and how we got that profile. Okay, so I'm going to show my AutoCAD again. So in the plan view, I identified those points, right? The edge of asphalt. I identified both of these points, right? Really, you only need one. Which one? The one furthest away from the intersection. So if I drop a perpendicular to the center line, whoops, this one. So this one here governs. So I would ignore this. Okay, whoops, I would ignore that one. So that's the station for my low point, right? So edge of asphalt down 0.5%, then it's all positive. Up 0.5%, up 1.5, up 0.5% all the way to here, and then up 1.5 all the way to not the gutter, but the edge of asphalt. That distance is 0.3. So I project those points, I connect the dots, and once I have the station values, then I go into right click and I go to the profile properties. Oh, not the properties, sorry, the profile geometry. And I look at the table and I start at the beginning on the grade outside and I type these in order. You have to start at the beginning because whatever I type here is going to change the next elevation. And then whatever I type here is going to change the next elevation. And whatever I type here is going to change the next elevation. So you have to start at the beginning in this column, the grade out column, and type in all the slopes as required from the beginning to the end. Okay. So that's how our profile is designed. Okay? And that's where we left off last week. And what I want to continue with today is the discussion now. What we're working toward is creating a corridor model. And the corridor model requires 3 parts. The 3 parts that are required to build any corridor, if you remember from highways, if you've taken highways, is you need to know the you need to have the horizontal alignment, which we do. So you should all have a horizontal alignment now as part of assignment 2. You need to have a vertical alignment, the design profile, which I've already discussed, and some of you I know have already started doing it. So that's the design for the profile. And then the third element, there's always 3 building blocks, is the cross section, right? The typical cross section, which in Civil 3D is called the assembly with the sub-assembly parts. And I'm going to do something very, very simple. Okay, you might remember from highways, a assembly with the sub-assembly parts that had all the different asphalt layers. Remember, there was 2 layers of asphalt, 2 layers of granular. One side had a boulevard with a sidewalk. One side had a boulevard with no sidewalk. All that stuff, right? All the cross-sectional. I'm not going to do that. I'm going to do something very, very simple. And it is common practice to keep this part of it simple. And you'll see all we really want to do is have the finished ground. I don't need all the underground layers. For estimating purposes, I'm not going to use the corridor. I'm just going to use it for the geometry I need to go forward. The corridor is a requirement to do all your grading design and your servicing design. You'll see how that all fits together in the second half of the course. So I have my plan. I have my profile, my design profile. I need a cross section. So to determine the cross section, and this is pretty much review from what you did in highways. So if you want to go back and use the modules that you did in highways as just reference, you can. I don't have them on the course, but you can certainly go back and look at yours. But this is pretty much review, and I'm going to use two simple things. One, I need a corridor. To get the corridor, one of the first things you need is the assembly. So this is the point that connects the cross-section elements to the plan and the profile. So create assembly, and we're going to do more than one, but this is the basic one. So I want to determine the typical 20-meter right-of-way. Okay, and you can accept all the defaults. That's just the name. Say okay and pick a point. I generally put it either on the end or the beginning. I'm going to put it at the beginning, right? When you click, it's going to zoom in on it. And that's all it is. That's the connection point. That's the thing that helps you connect the cross-section elements to the plan and the profile elements. Okay, so that's the building block. Now we build from this assembly all the sub-assembly parts. So we have to go to our library. So again, to corridor, and we go to the tool palettes. And of all these tool palettes, we're only going to use, out of all these tool palettes, and there's some really complicated stuff, I'm going to keep it very simple. I'm going to go to the generic tab, and I'm only going to use this, what's called link with a width and a slope. So this is the only one I'll ever use in this course. Okay, and for the most part, when I do design for subdivisions, that's almost exclusively the only one I ever use. I'm not designing highways. I'm not designing, complicated roundabouts, or I'm not doing anything, multiple lanes and all that sort of stuff. Right? I'm not doing transportation type work. I'm doing simple subdivision roads, which are generally local collector roads. When you get into arterials and freeways, yes, all the other stuff in the library starts to make more sense. But for the most part, for what the kind of stuff that I'm using or doing in residential subdivisions, this is probably one of the only ones you'll ever need. There are others that are useful, but this is the basic one that I always use. So before I start to use this, we need to look at what the design is. Okay, so I'm going to go back. Let me see if I can do this. I'm going to go back to the standards and look at the cross section. So I'm going to go to the course, and we go back to, actually, if you go to your desktop, which is where I kept all this, right, into the course code, under downloads, under module 2, you should have the engineering standards. So we're going to look at this, and if we go to transportation, you'll remember the cross section. I think it's 164. This is the typical cross section, right? So what we want to look at is all the different pieces from the center to the right of way, right? So from the center line of the road, we want to go down at 2% to the edge of asphalt. Then the gutter has 3 basic faces. This plane here to the gutter, this almost vertical face, and then the top, flat top. And then from there, we want to go all the way to the street line. So there are 1, 2, 3, 4, 5 pieces. And then it's symmetrical. It's got 5 on the other side. Okay, so we need to read this together with this as well. We need to look at these dimensions. So what I want to determine, and we'll do this together, what I want to determine is for the cross section, I want to know how wide each plane is horizontally, and I want to know the slope of each plane. Okay, and there's 5 elements to do. So let me see if I can do this as a sketch. So here we are again. So let's assume the center line is here. The center line of the road is here, so I'm only going to draw half. So this is the center line of the road. I want to go down to the edge of asphalt. Then I want to go down to the gutter. Then I want to go up the curb face, and then I want to go to the back of curb. And let me just draw this in for reference. Here's the curb and gutter, right? We're not going to need this. I just want these 3. 1, 2, 3, and then I want to go all the way to the street line on the other side. I need to know horizontally how wide all these pieces are, and I want to know the slope. So how many meters horizontally are all these pieces? And what's the slope? At what slope? At what slope? Okay. So if we remember some of the dimensions, you remember from the center line when we offset to what I've called the edge of pavement, this point here, what's the width? What's this width? Anybody remember? Here's your offset from center to edge of pavement, which is the gutter line. What was this dimension? No. 4.25, that's right, 4.25, because the edge of pavement dimension was 8.5, so half of that, 4.25, okay? If the entire right-of-way was 20 meters, how wide is half of it? So this is 10 meters. That was the offset from the street line to the center to begin with, right? So we offset 10, and then we offset 4.25 on both sides. That's how we drew our edge of pavement. So if this is 4.25, how do I get from the gutter to the street line? What's this dimension? What's this dimension here? That's right, 5.75. Okay, so now we need to break that down further. If you look at the gutter, how wide is the gutter? What's this dimension from here to here? What's the dimension from the edge of asphalt to the gutter horizontally? Yep, 0.3 meters. What's the dimension from the gutter to the back of curb? Remember this dimension? From the gutter to the back of curb. That was another offset you used to draw your back of curb line. 0.2, correct. So 0.2 meters. Okay, we're getting there. We're almost there. Sorry, I just want to turn my sound on. Okay, so then we got to break it down. What's the dimension from this point to this point horizontally? What's this gap? This distance here from the gutter to the front top face of curb. And let me show you the dimension. What's the horizontal distance from the gutter point to the top? Ignore the fillets, the radius, 25 and 50, ignore those, right? What's the horizontal distance from the gutter point to the top face of curb? Yeah, the last two, Warren and Trung, you're right. So this is 0.05 meters. Sorry, 0.05, right? To 50 millimeters, which is 0.05. So if I go back to my sketch, the dimension from here to here horizontally, this distance is 0.05. And then what's the distance from the front face to the back of the curb? What's this dimension? From here to here. Right, 0.15. Okay, so the three dimensions horizontally on the curb and gutter are from here to here horizontally, 300. From here to here horizontally, 50 mils or 0.05. And then from the front top of curb to the back top of curb is 0.15. So these are the three horizontal distances. If we know those distances, if this is 425, what's the dimension from center to edge of asphalt? What's this dimension? Yep, 3.95. So we take 425, that takes us from center to gutter. I'm going to subtract 0.3 to get 395. Very good. And if the boulevard is 575 from gutter to street line, what's the dimension from the back of curb to the street line? What's this number here? 5.55. Okay, does everybody see where those dimensions are coming from? We started with these two, very general. How do you get from center to gutter? How do you get from gutter to street line? Then we looked at three horizontal distances that are related to the curb and gutter, and then we discounted some of the distances to get this plane. So these are the horizontal distances. Okay, those are the widths of all the cross-section elements. Now I want to know the slope of each piece. Okay, let's do a couple of simple ones. What's the slope of the pavement? What's the slope of the asphalt? 2%. Okay, and relative to center, it's negative, so negative 2%. What's the slope of the boulevard? Back of curb to street line. Slope of the boulevard. Anybody see it? Oh, the screen is frozen. My bad. Sorry. So I can bring this back. Can you see it now? Can you see my hand waving back and forth? Anybody else? Okay, so let me go back to the dimension. Can you see the cross section? Town of Richmond Hill cross section. What's the slope of the boulevard? 2%. And it's positive. Away from center, it's actually positive. So let me go back to my sketch. So this is negative 2%, this plane, and this one is positive 2%, plus 2%. Right? If you're moving from center to the outside of the road, you're going down at 2%, up at 2%. So this is at 2% negative, and this is at positive 2%. Right? So the width is 395, it's negative 2%. The width is 555, and it's a positive 2%. Okay. What about the slope of these lines here? Let's get the gutter detail back. What's the slope of the top of curb? What's the slope of the top of curb? Yeah, it's perfectly flat, 0%. Very good. What is the slope of the gutter? Anybody know the slope of the gutter? Well, it's not on here, but you can calculate it. You can find the rise and divide by the run. What's the rise of this line? What's the rise? Okay, you're ahead of me, Brian. What's the rise? The rise is right here, 25 millimeters. So if we know the rise is 25 and the horizontal distance is the run, 300, we can take 25 divided by 300 times 100. Yeah, wait, very good. So 25 divided by 300 times 100 is actually, and it's negative, right? From center to the edge, it's going downhill. So we're looking at a slope of negative 8.33333. It goes on forever, 8.33%. Okay, so this is going to be negative 8.33. A horizontal distance of 0.3 with a slope of negative 8.33. And then this last piece, this face of curb, this almost vertical piece, let's go down to the dimensions. What is the rise of this piece here? What's the vertical distance from this point to this point? That's the rise, yeah. And what's the run? What's the horizontal distance between the gutter and the front face of curb? What's the run? 50. So take the rise, 150, divide by the run, 50, and multiply by 100. No, not 200. The rise is 150. The run is 50. So 150 divided by 50 times 100. Rise over run times 100 gives you the percent grade. So Trong, I think you got it right, 300%. And is it positive or negative? Is it positive? Positive, yeah. So the slope of this line, the slope of this line here is a rise from here to here is 150. The run is 50, you remember, horizontal 50. So if I take 150 rise divided by the run, 50 times 100, the slope of this vertical face here, this piece here, is positive 300%. So now I have all the horizontal distances, 395, 0.3, 0.05, 0.15, 5.55. Those are all the horizontal distances for each piece. And then I have the slope of each piece. This is negative 2. This is negative 8.333. This is positive 300. This is 0. It's perfectly flat across the top. And then this one's positive 2%. So you need to know this these dimensions, these distances, and these slopes, because what we're going to use is the width and the slope, the width and the slope of each piece, the width and the slope, which is the name of the piece we're going to use. Watch. We're going to go back to AutoCAD. the link with the width and the slope. So you need to know all those widths and all those slopes. Okay, so if you didn't write them down, that's okay. But you should do the calculations. You should figure this out, because this is another standard calculation you would perform. If you want to use this cross-section elements, you have to know the width of each piece, you have to know the slope of each piece, okay? And the slope has to be positive or negative in the direction of center to the outside of the road to the street line in this particular case. So what I'm going to look at now is, I'm going to, remember I created this and I named it standard 20-meter right-of-way, and I'm only going to use this link with slope. So when I click on it, it's going to bring up a dialog box, and this is where you can set the width. So the first width is 3.95. 3.95. Oops, where'd it go? Sorry. So let me just lock my window here. Okay, so I want to use this one here, and I want to change the width to 3 point. Well, let me change it. Hang on a second. I don't know why it's doing that. Am I in the middle? Oh, I'm in the middle of another command. So I want to use this one, and I want to type in 3. Anybody else? Try this one more time. I want to use this, and I want to type in, I'm going to do the right side, and I want to use 3. Well, let me type it in. Okay, hang on. There's another way. I don't know why it's acting up. Let me just try something. My drawing seems to have a problem. Let me just see if I can fix it. Okay, so get rid of this, save. Okay, let me try it again. So under corridors, I want the palettes, subassembly tool palettes. And under the generic tab is the link with slope. Click on that and type 3.95. Okay, if it doesn't let you type it here, I don't know why it's doing that. I've seen the same problem with, some students have described this problem to me before, and this is the workaround. I think you have to select insert. There's 2 ways. You can set the value before you start. There, now it's working, 3.95. Tell it how wide you want it to be, and tell it what the slope should be. The slope should be -2%. Okay, so you can set the parameters first, or you can create something and then revise it. Okay, so it could go either way. I don't know why it wasn't working, but I've seen that before. Oh, hang on a second. Oops, I got some background noise here. I'll be right back. Hello? Sorry, that was an alarm going off. Problems of working from home. Sorry about that. So let me go back here. All right, so let me start that again. So once you have your assembly, I'm going to start right from scratch. Okay, so I'm going to go to corridors, create the assembly. I'm going to pick a spot, give it a name, 20-meter ROW. It's just a name. Leave everything else. Click, and it'll zoom to it. Then you want to go to your palettes, corridor, subassembly tool palettes, and you're only ever going to use this one. So in the generic tab, you're only going to use link with slope. Click on it. And again, you should be able to set your parameters first. So 3.95 wide. I want it to be -2 down from center. And I'm going to draw, you could do the left or the right. I'm going to do the right side just so it's consistent with the hand sketch that I just did. So when I click, it's going to put that plane in. So that's 3.95 horizontal and -2%. The next piece, if you remember, is the gutter, 0.3 wide, and the slope is -8.33%. So when I click here, and now I'm going to pick not the center point, but the first point on the outside of this first plane. So click, there's the gutter line. Then I'm going to change this again, 0.05 horizontal, and it's +300. You don't need the plus sign. Click the last circle. Whoops, do it again. Sorry. So this one is 0.05 with a 300%. Oh, shoot, where did it go? Pick again, sorry. 3.05, 300. And then I'm going to choose, I don't know why it keeps jumping. Sorry, my apologies. 0.05. And now it's not working again. 0.5, 300, and click. And sorry, let me try it one more time. This is causing a lot of grief. It shouldn't be this difficult. I don't know why that's misbehaving. Let me try one more thing. Try this one more time. So, corridor, subassembly tool palettes. I'm not going to dock it. I'm going to click on this one. I want this to be 0.05. Where did it go? .05. I try this one last time. It shouldn't be this difficult. Tool palettes, generic, link width slope, 0.05. Okay, here's the workaround. I'm going to create this 3 meter at 2%, but then I'm going to change it. So I'm going to click here. One of them and do that. Oh, I know why. Let me start again. Sorry. Link width slope. Right side, 3.95. My apologies. I don't know why it's not behaving. 3.95. I think we need to insert the circle next to the current assembly. Yeah, subassembly. Let me just give it another try. I've never had this problem before, not to this extent. Usually you're able to change the parameters before you draw it, which is this thing. So back to here. Change the parameters. Okay, so if it doesn't do that, just accept the defaults and draw it. So I'm just going to draw this piece. Again, my apologies, I'm not sure why this isn't working. I'm going to draw the piece. Select assembly. I'm going to click here. That's 3 at 2%. Notice it's going uphill instead of downhill. Let me just put in 5 parts. This is another way of doing it. So that's 1, 2, 3, 4, 5. These are all 3%, 3 meters at 2%. Now I'm going to go in and change the parameters of each one now that I've created them. So this one here, I don't want it to be 3 meters. I want it to be 3.95. And I want it to be minus 2%. So that's the plane of the asphalt. The next piece should only be 0.3 meters wide. And it should be down at negative 8.333. The next piece should be only 0.05 meters wide, but positive 300%. So now you'll see the face of the curb. The next piece should be 0.15 wide, 0%. So there's the top front face of curb. So there are the 3 planes from your curb and gutter, these 3 pieces. And then the last piece should be 5.55 at positive 2%, which is the default. So there's your standard half of 20 meter right of way. Okay, so there's 2 ways of doing it. The most direct way is if it allows you, let me see if I can draw the right side. If I link width slope, and if I want to draw the left side, and let me change the parameters. If it doesn't let you change the number here, just accept the defaults. So I'll put in a 3 meter wide on the left, and I'll put in for the gutter, for the face of the curb, for the top of curb, and for the other boulevard, and then you can go and change the parameters of each. Okay? So that's another way of doing it. Just accept the defaults, create the subassembly, and then change the parameters to the width you want. Minus 2% and so on. Okay? I have one side, if it's symmetrical, which this one is, if it's symmetrical, you can actually mirror the parts, but you can't use AutoCAD mirror. You have to use the Civil 3D mirror command. What you want to do is select all the sub-assemblies. Do not select the centerpiece. This is called the assembly, and these 5 parts are the sub-assemblies. So you only select the sub-assemblies. You right-click, and you use this mirror command. This is not an AutoCAD command. This is a Civil 3D command. Okay, so again, if it's symmetrical, choose the sub-assemblies. Do not select the assembly point, just the sub-assembly, the parts. Right-click mirror, and then choose the center point as the mirror point, and this will mirror vertically on that piece, and you get the other half of the road. Okay, so that's your typical cross-section for 20 meters. As a double check, the distance from this endpoint, to this endpoint should be 20 meters. Right? And that's how I know I drew every piece correctly, because the sum of all the pieces on one side is 10. When you mirror it, it's 10, total width of 20. So that's a double check that you can perform. Okay. So again, if you want to create this, usually you're allowed to change the parameters. I don't know why it's not working for me. Let me try it one more time. So I'm going to go to corridor, create assembly. I'm just going to call this temp, something to practice with. I'm going to put it here, and then I want to use link width slope. And usually, like I said, lets you change the parameters before you start. If it doesn't, if it won't let you type here, then just create it with the standard 3 meters at 2%. So I need 1, 2, 3, 4, 5 pieces. And then you can revise each piece. And notice when I created this, the default is the left side. If you want the right side, you have to change it. Okay, so I was doing the left side all the time. So if it doesn't allow you to change the parameters here, just accept the defaults and then revise the pieces. So this one, again, I want to change it to a width of 3.95 with a slope of minus 2. This piece here, I want to change it to a width of 0.3 with a slope of negative 8.333. That'll give you the gutter. Then I want the face of curb, which is only 0.05 wide, but it has a 300% slope. There's the front face of curb. The next piece is only a width of 0.15 with a slope 0. It's perfectly flat. And then the last boulevard piece there is going to be 5.55 with a positive 2%, which is the default, so I'll accept that. If it's symmetrical, choose the sub-assemblies. Don't choose the center point, the assembly point. Right-click, mirror. Pick that center point as reference, and it'll mirror it to the other side. And then double-check. End point to end point should be exactly 20 meters. Okay? Any questions about creating that? Didn't go as smoothly as I had hoped. I usually like to change the dimension before I draw the item, right? So I want to draw 385 at -2, put it in the drawing. Then draw the gutter dimensions, and then put it in the drawing and so on. If that doesn't work for you, like the problem I just had, just create it so you have something and then revise it. Okay, any questions about that? So let me get rid of this. If there's no questions, we can go on to build our corridor now, right? We have a horizontal alignment, right? We have a vertical alignment, the design profile, and we have the assembly with the subassembly parts. Now I can marry those three things into one more complex object, which is the corridor model. Okay, so let's take a look at that. Any questions before I do that? Go ahead, Claire. What's the question? Actually, here, let me change Claire, if you want to ask your question, let me change the settings so that you can share your audio. It's a small enough group. You can unmute yourself if you want, Claire, and ask me a question. Or type it. It's up to you. Yeah, you should be able to unmute yourself if you want.
Okay, Professor.
There you are. Yep.
A question to the at the beginning, like the class. It's about the low point.
Yes, the low point.
The low point.
You sent me an email about this, right?
Yeah. But
yeah, go ahead.
Yeah, but now my elbow is like the opposite. It is your means the low point always close to the individual like site. Individual subdivision.
Yeah, so if I draw the point, if I draw 2 points, right, there's always two.
Yeah. I have I don't know how to decide which one is the low point.
So this is the intersection here, right?
Yeah.
So of these 2 points, the one on center that is farthest away. So in my case, this is further away than this one. So you have to draw both.
You mean further away? Which one is further away from the intersection?
Yes, the one furthest into the subdivision. Because what that does is it puts your low, because we're going to need catch basins at the low points. So that puts a catch basin on the end of this curve.
Yeah.
And then it puts a catch basin across the street. Not on the curve, but on the line.
Okay.
Right? So then the catch basin station will be there, not here. So what we want to do is make sure that the catch basin is always on the straight line. So we use the one that's furthest away. Now, again, in my case, the one furthest away is this one, right? So if you look at positive chainage, it's the right side of the road. It depends on your geometry. It might be the right, it might be the left. The general statement is whichever point is furthest away from the intersection into the site.
Okay. So, yeah, for example, my elbow is my position is the same like you. Just the elbow is like up way. It's not related to the subdivision. It's just related to the intersection.
Yes, the one in furthest away from the intersection is the low point. You ignore the other one. Yeah.
Okay.
Trung, if you want. Okay. Does that answer your question?
Yes. So I think now I understand. It's not related to the subdivision, which way you're close to the subdivision. Yeah, okay. Thank you. Because I just stuck here. If I understand, I can do the next step. Thank you.
Yep. Trung, you can use it. You want to use something like this? You want to use one of these? You can if you want to, but for what I'm going to use the corridor for, I don't need anything underground. I just want the surface. I want the finished ground surface of the road. You'll see why. That's all I need. Okay, so I'm not going to use my corridor to do any quantity, granular asphalt. I'm not going to do my estimate that way. Okay, and in this course, we're not doing any estimating. We're just going to design. Next semester, we're going to use the same technique. We're only going to draw the finished ground. So if I go back to the cross section, right, nothing underground. It's just the finished ground, the surface you would walk on or drive on. The underground layers, the volume of asphalt and granular and concrete for curb and sidewalk, I'm going to do that manually. I'm just going to get areas times depth. You'll see that the estimating process is a little simplified. For roads, it's useful to have all the underground layers, but for subdivisions, it's not that. It's more trouble than it's worth. So I don't know too many people who use it for local roads. Really, this is all you need. Okay, and you'll see what the purpose of this is in the second half of the course. Right, this is key. So let's build the corridor. Okay, so to build a corridor, this is the process. It's very, very simple. You go to corridors, you say create corridor, and then you have to give it a name. I'm going to call mine roads. I only have one road, but I always call it roads. Next semester, this will make more sense. I create one corridor of all the roads together. I don't have a corridor for each individual road. So if I have a subdivision of 30 roads, I don't have 30 corridors. I only have one corridor. I add them all to the same corridor. Okay, and more about that next semester. It doesn't make a lot of sense today, but next semester it will. So now you have to give it the three pieces. Okay, so once you give it a name, I need a horizontal alignment. There's only one. I need a vertical alignment. Now there's two. Be careful here, right? There's the existing ground, the red dashed line, and then there's the green one, the proposed one you want. So be careful here. Make sure you choose the design profile, not the existing ground surface profile. And then you need to choose the assembly, 20-meter right-of-way. So the plan, the proposed profile, and the cross-section. These are the three basic building blocks of any corridor. That's all you need. Okay, so give it a name, plan, profile, cross-section, say okay, and it'll build it. Okay, once you get this, just say okay, let it build. We're going to go back in and revise it. Okay, so say okay, rebuild the corridor, and it builds the corridor for you. So this is the corridor. Okay, it's very, very crude right now, but it needs a little bit. It needs a little bit of work. Okay, when you look at this corridor in 3D, remember it's a 3D model. You'll see two issues right away, which are going to be a problem now, and you'll see the same problem later when we get into the details of finalizing this. This is not in its final state right now. So if you click on it, you can view the object or object viewer just like a surface in 3D. And if I click and hold and rotate, you'll see in 3D the road. But at the beginning and at the end, there's a spike. Do you see that? Right? It goes from 0, then it goes to my design profile, and then it goes back down to 0. It's got spikes. Now, why are those spikes present? Well, by default, when you build the corridor, it starts at the beginning of the horizontal alignment, and it goes all the way to the end of the horizontal alignment. So that's the range for the build. Your design, however, does not start at the beginning of the alignment, right? So my alignment starts here at this station value. But my profile doesn't start until the edge of asphalt. So anything between the beginning of the horizontal alignment and the beginning of the vertical alignment, if there's nothing there, if this profile doesn't extend all the way to there, it assumes the elevation is 0. Same thing on the end, right? My design ends here, but my horizontal alignment goes all the way to here, right? So again, at the end, it wants to build to here. There's no design. It assumes an elevation of 0. So the way to remedy this, just to keep the model from misbehaving that way, right? So I'm going to look at it again, right-click, Object Viewer. You'll see at the beginning and at the end, there is no vertical design at the beginning of the horizontal alignment. There's no vertical design at the end of the horizontal alignment. So what we do, just as a housekeeping, is we click on the road, we take this grip, and we snap it to this point here. That's the first profile point. And we do the same at the end. Take this grip, and snap to this node here. That's the end of the profile design. So now the range for the build is not the limit of my horizontal alignment, but the limit of my vertical alignment. And if I look at this in 3D, the spikes should be gone because there's no 0 elevations anymore. Right, so there's the road. Those spikes are gone. Okay, so by default, the range for the build is the beginning of the horizontal alignment to the end of the horizontal alignment. I just grip edit the ends so that it coincides with the beginning of the vertical alignment and the end of the vertical alignment. Remember, these are the points where my profile design starts and ends. Okay, so that's how you get rid of your spikes. Another thing you'll notice is the frequency, right? See these blue lines? These blue lines are actually the cross-section elements. So let's look at this in more detail. So if I zoom in on those blue lines, you'll see your assembly with sub-assembly parts. See here? There's the center point. You don't get a line in the center, but if you look on the edge, you'll see, right, the plane here, 2% down. Then you see the 1, 2, 3 planes of the curb and gutter, and then you see the boulevard. So you can see that it's trying to build like a stick figure, a 3D stick figure of the surface of the road, okay? And it's based on the cross-section data, okay? The frequency, how frequent you see this cross-section information is one of the parameters you have control over. So I'm going to click on here, right-click, go back to corridor properties, and I'm going to change under parameters the frequencies. I'm going to set them all once and for all. As you add to this model, you have to change this all the time. So by default, all the frequencies are 25 meters. Okay, so you can see 25, 25, 25, and 25. Along a tangent, I would say go every 3 meters. These are numbers that work. Okay, you can go bigger or smaller. The smaller the increment, the more accurate the model. Okay, but if you go too small, you'll end up with a lot of data and not necessarily any more detail. Okay, so let me show you what 3 meters does. So on the tangents, I'm going to go not every 25 meters, but 3 meters. On all the different curve types, okay, so our horizontal curve, a circular curve, I'm going to go every 1 meter. On a spiral, we don't have any, but I'm going to go every 1 meter. So the horizontal, circular curve, and spiral curve, if I have one, I want a cross section every meter. And then if I have a vertical curve, which we're not going to have any, but if I had a vertical curve, I'd want to do the same in the vertical. So on the tangents, on the straight sections of road, 1 meter. But if I have a circular curve or a spiral curve or a vertical curve, I want a cross section every meter. And it will continue to build the surface of the road with straight lines. But if you make these frequencies smaller, you'll start to mimic the curvature better. Let me show you what I mean. So I'm going to say okay, I'm going to say okay. It's going to rebuild the corridor, and now wherever you have a curve, you're going to see a tighter grouping, right? So on a tangent, every 3 meters, so the distance between these blue lines is 3 meters, and then when you go around a curve, every 1 meter. So now it starts to look more like a curve, right? And same thing here, I have a curve, so every 1 meter. So at a glance, it looks curved, but if you zoom in, it's a bunch of straight lines. These are actually just straight lines. If I take the center and I offset it 3.95, remember 3.95 to the gutter, to the asphalt edge. If I zoom in on that, here is the actual curve, right? That's the curve, but it's approximated by a bunch of straight lines. If you zoom in, right, it's a bunch of straight lines that makes it up. So if you change your frequency, you can mimic the curve. Yep. Okay, so it looks like a curve, but if you zoom in, it's not. The smaller you make that frequency, the more accurately it mimics the curve. Okay? But these are pretty good parameters. Every 3 meters on the straightaways and every 1 meter on the curves gives you a pretty good representation. So I'm going to look at this in 3D again, and you can clearly see, you know, how close the cross sections are on the curve. Every 1 meter, and that's the distance along the center line, right? Center line 1 meter. Center line 1 meter. Notice on the inside they're closer together. On the outside they're further apart, right? Because it's just wrapping it around the center of the alignment. Horizontal, vertical alignment. So the horizontal position comes from the horizontal alignment. The vertical comes from the profile, and then the cross section comes from the assembly with the sub-assembly parts. Okay, that's basically it, right? Tell it horizontal alignment, vertical alignment, cross section. And then it'll drag it along. Imagine that the center line, horizontal and vertical, is like a clothesline, and then that the sub-assembly with this assembly with the sub-assembly parts is like a coat hanger, and you're going to drag that coat hanger along the horizontal vertical alignment, and that's the shape of the road. Okay, so we have these good visualization tools, the object viewer in 3D and so on, so you can actually see what's going on. So that's what the basic corridor looks like. Okay, there's 3 things not quite perfect about this yet. Okay, we're going to get to that. It does not represent the elbow correctly, and it does not represent the cul-de-sac correctly. Even the intersection, right, doesn't work too well, right? The road looks like it wants to go all the way to here, when really it should stop at the curve and go around, right? It should really respect this alignment. The street line should be way out here. The street line should be way out here. So when it comes to this corridor, it's pretty good, right? On the straightaways, your typical 20s, it's perfect, right? Between the elbow and the crescent, everything along here is perfect. Now we have to manage the bulb and the crescent and the intersection. Okay? So like I said before, when you're doing these roads, the standard typical width pretty much takes care of itself. You spend most of your time dealing with these areas where you have these weird widenings, right? Cul-de-sacs, crescents, and intersections. That's where most of your time is spent, right? So if this was a standard 20-meter right-of-way for 30 kilometers, it would be fine. But if you put in an elbow, oh, now I concentrate on that a little bit. Oh, there's a cul-de-sac at the end, and now I got to concentrate on that as well. Oh, there's an intersection, I got to deal with that. So most of your time is managing the oddly shaped things as opposed to the standard widths. Any questions about the corridor so far? Okay, it's the three basic building blocks: horizontal alignment, vertical alignment, cross-section data, which is the assembly with the sub-assemblies. You marry them all together. Then you can limit your range, not horizontal range, but vertical range, so you don't get those spikes at the beginning and at the end. And now it's almost done except for the elbow, the intersection, and the cul-de-sac. Okay, so let me show you, because everybody did the assignment. So I've got all 40 students' assignments, and I'm going to draw the crescent and the cul-de-sac edge of pavement. So if you got this wrong, when are you posting assignment 3? I just have to make it available. Right? So it's already on there. I just got to make it available. Today is the answer, Stephen. Let me go back now and do a little bit of review. I want to go back and draw the edge of pavement for you on this entire subdivision, okay, with the crescent and the elbow. And I'm going to look at the standards to do it. So right now, this is on a layer called 0, just like anything else. I'm going to put it on the layer called corridor. So not 0, let me put it on a layer called corridor. So C corridor should be a layer in your drawing. Corridor or C corridor, C core. I'm going to put it there on the corridor layer. Okay, and you'll see it's frozen. So it's frozen. So if I want to see it again, I'll thaw it. Okay. So it's no longer on layer 0, just like the surface, right? When you build these things, you don't want to have anything on layer 0, so put it on a layer called corridor. And then I'm going to just freeze it. I don't want to see it right now. So let me review how to draw your edge of pavement again. I'm going to get rid of these. I don't need them anymore. Again, you can put them on a frozen layer, or you can delete them. It's up to you what you want to do. So this is just a bit of review of the assignment that you were supposed to do, because if you made any mistakes here. So if you didn't get 4 out of 4 on the alignment, here's where you went wrong. So if you offset 10 meters, you get to the center. So there's the center and there's the center, and you do that all the way along. Okay, that center line has to go all the way to the street line. Okay? A couple of people didn't send the alignment to the center of the street line. They ended their alignment at the center of the circle. So this was a comment a couple people made. So your alignment goes all the way to the edge of the subdivision, not to the center of the circle. That's wrong. It's too short. You have to take it all the way along to here. And if you stopped it at the edge of asphalt or edge of pavement, it's also wrong. It's got to go all the way to the street line. At the other end, it doesn't stop at the center line of the existing road. It goes all the way across the street to the opposite street line. So that was the extent. And then if you put 0 in the right spot and you have the correct radius here, this radius should be 14.5 from the crescent standard. You should have a total length that matches what I had here. That's how I marked it. So you would have got 4 out of 4. So is the center line in the right spot? Is the length at the beginning and at the end in the right spot? At the beginning and the end point at the right spot, and so on. So that's the center line. There was 4 marks for that. To draw your edge of asphalt, then you can offset that by 4.25. Not asphalt, edge of pavement. Sorry. Offset 4.25. There's basically where it is. It's no good in the intersection. How do I draw the intersection? Well, I'm going to draw a line. Near point, oh snap. I'm going to use my end point. I'm going to draw a line from here to here to here. I'm just tracing the edge of asphalt from the topo. It's not a straight line. It's a connect the dots kind of an exercise. And then I'm going to fill it with a radius of 7.5. My gutter line with this line, that's the wrong thing to do. This is asphalt. Sorry, this is the edge of asphalt. This is the gutter line. So they're two different things. You can't do that. What I do is I offset 0.3. If there was a gutter, where would it be? It would be right here, 0.3 meters away from the existing edge of asphalt. And now I can fill it a radius of 7.5, my gutter line to the theoretical gutter line of the road. And then I'm going to erase, explode this, and I'm going to erase this. So the curve comes around and the gutter is in a position so that it's 0.3 meters away from the existing edge of asphalt. You have to do the same thing on the other side. Offset 0.3. Most people got this right. And you have to do both sides separately because they're not parallel. 7.5. Fill it this with this. And then again, I'm going to explode this and get rid of this line. And now I don't need the traced lines anymore. And that's what your edge of gutter should look like. It comes around at 7.5 meter radius and it does not touch the asphalt. It would touch where the theoretical gutter would be. So that's all we do. So that's how we transition from a urban section to a rural section. The curb comes, goes around, and stops as soon as it's parallel. Okay. In here now, to draw this, I'm going to go back to the standard. So I want to interpret this for you in case you weren't sure. This would have been the standard here. The approach to drawing the cul-de-sac and the crescent is the same. I'm going to use the exact same approach. There are three arcs. There's this curve here, there's this curve here, and this curve here. There are three arcs. Okay. In this one, there are also three arcs, right? There's the main arc in the center, and then there's this curve and this curve on this side. There are three arcs. The approach is exactly the same. Draw the one in the center first, the middle one, and then the other two will fall into place. Where does this arc go? Well, the center of it is take the property line on the opposite side of the road, offset it 4.5. That's the center of the circle, and then the radius is 12.5. So here's how you draw that. I'm going to offset 4.5, this straight line, and this straight line. And then where they intersect is the center of the circle out here. So you could either fill it with a radius of 0, fill it with a radius of 0 to bring these two together. There's the center. Or you can use your O-snaps. And the O-snap you want to use is intersection. Use your intersection O-snap. And you use it in two parts. Okay, I'm going to draw a circle where the intersection of these two lines. So instead of, see how if I click here, see how it's just an X? The little marker is just an X. Well, if the actual location of where those two lines intersection is not actually shown, instead of picking one location and draw from an intersection, I can pick one line. I can click here, intersection. See that dot, dot, dot next to the X? That means I can pick two things to find an intersection. So I can go here, pick one thing because the intersection exists, or I can click here with that dot, dot, dot present, and then click the other thing and it'll solve it for me. There's the intersection of those two lines. That's the intersection. Okay, and what's the radius? 12.5. That's where the center arc goes. Okay, so your O-snaps, you have to really use them properly. If you want to draw a line with an intersection that exists, whoops, sorry, too many clicks of the button here. If you want to draw and click on a spot where the intersection is explicitly shown, then it's a one pick, right? So L, I, and T, right? If this intersection exists, you can pick it. If you don't want to snap there, if you draw a line, INT, you can go off the line and it gives you that dot, 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 and then you get to pick two things. I want the intersection of this thing with this thing, and it solves it for you. So you don't have to necessarily fillet these two together. Okay, so that's how I do it. It's up to you. Again, these are just little tips and tricks that are along the way. Now, the last two curves, if I go back to the standard, this arc and this arc are the same. The radius is 3575. So now what I want to use is a fillet command. To fillet, I need to break the circle. There's a couple of ways of doing that. BR for break, and I can click on the circle and then break it. That's one way. Or I can trim it. Trim it between two lines and break it that way. It has to be an arc. And then I use a fillet with a radius of 35.75 between this arc and this straight line, and this arc and this straight line. And that's how you draw your three arcs. You start with the center one, and then you use the fillet command on either side. And that's how you get your gutter line on the outside. Okay, and then you don't need these construction lines anymore. On the inside, on the inside, it actually has a radius of 10.25, which, if you do the math, it's parallel to the inside. If you offset the inside to here by 425, if you list this arc, whoops, if I list this arc, it's already 1025. So it's symmetrical. So your cross section is only getting wider on the outside, not on the inside. The horizontal distance from the center to the edge of pavement on the inside is consistent, 4.25 all the way around the inside. It only gets wider on the outside. So that's how you draw this eyebrow out here. The arc here has the same thing. Draw the one in the middle first, then use the fillet command. Okay? And if you interpret this, the center arc has a radius of 15, and it's right in the middle of the right-of-way. Right? All these 1, 2, 3 arcs are all concentric. They have a center of the arc there. So I'm going to draw a circle at the center of the right-of-way, 15 meters. So I'm going to draw a circle, CEN 15. And then I want to fill it. Again, I have to either break it or trim it. I can't fill it to a circle, so I'm going to trim between these two lines this. Go back to the standard. And it's going to tell me the radius here is 36.5. Fill it with a radius 36.5, and that's how I get from here to here. That's how I get from here to here, and now I have my what I call pavement, which is the gutter line location. So that's how you draw those. I didn't show this to anybody. Some people asked me, how do you do it? And I said, figure it out. And most of you did a very good job. There was a couple that had a few issues. This was probably the most complicated thing because you had to trace and offset the edge of asphalt. But this one and this one, although the geometry is different, the technique is exactly the same. Draw the one in the middle first and then fill it to get the arc on either side. Okay. So those of you who got 4 out of 4 on the third item did this perfectly. Okay. If you didn't have the intersection right, you lost a mark. If you had the elbow wrong, you lost another mark. If you got the cul-de-sac wrong, you lost a third mark. And if you didn't have the standard width, if this distance was not 4.25, another mark, right? So you had to have the standard width correct, and then the 3 special areas: intersection, asphalt, intersection, cul-de-sac, and crescent correct. So that was the 4 marks there. Those things need to be done correctly because they have an influence on where you draw your points, right? If I want to know where this zone ends, right, I want to draw a line from the end of this arc, perpendicular to center. I'm going to extend that to both sides of the street line. That's the last time you have a standard 20-meter right-of-way. This is 20 meters. 20 meters. Beyond that, it gets wider and then narrow. And then where do you get your standard 20 back? Well, from the end of this curve, perpendicular and across to here. And that's where your standard 20 meter starts again. So between here and here is where you have your kind of abnormal width. And this is the point, the station value at the beginning and the station value at the end of the zone. So that's where you put your point. That's one station I need. This is another station I need. And then I project them. You might remember this. If I go to profile view, project these points. There's more, but let me just do these as an example. When I project them here, and I'm going to bring them into range, I'm going to use existing ground because it's not the vertical I'm interested in, just the horizontal. Where's the station value? This PVI, the beginning and in the end, the PVI location of the profile is born from these 2 points which come from the plan. So if you drew this wrong, if you drew these arcs in the wrong spot, then these points would be in the wrong spot, then these profile stations would be in the wrong spot. Right? So that's what I mean. That's why I highlighted. If you got your email from me today, there's 2 highlighted areas. The second one, the third item down, I think. If you drew this wrong, if you didn't get 4 out of 4, then your points and profile are going to be in the wrong spot. Now, if they move, right? If you move this, if you redraw that correctly and move it, right? In the profile, it changes position. And you say, oh, this PVI should be over here, node. Right? And then you go back and you change the slopes so that it all works. Right? Go back to here, and then just type in all the slopes again. If you move a point, then you have to type in all the slopes again. See some questions on that. So 4 out of 4, 2 out of 2. I think there's 2 of them that are 2. There's 4 that are 2 out of 2. Hang on, there's 2 that are worth 4 out of 4 each. Yeah, sorry, it should be 4. So there's the alignment should be 4 marks out of 4, and then the edge of gutter back a curb should be 4 out of 4. So it's 8 marks. I might have said it wrong in the email. I forget now. I'll take a look at it again. Yeah, I think I might have stated it wrong, right? But there are 2 highlighted spots. If you didn't get perfect on those 2, then you have to fix it. All right, so that's how you draw the elbow and the cul-de-sac. Here, again, if you draw that correctly, that's another mark. Okay? And again, you can't mirror. Watch this. If I mirror on center this arc, near, near, I'm not going to get the same solution. They're actually different. See, they're 2 different things. Why? Because the existing edge of asphalt is not a consistent bearing, right? There's a bunch of pieces, so you have to use the piece on one side, the piece on the other side. Otherwise, it won't work. So you can't draw one and then mirror it. You have to do each one separately, the way I did it. North arrow should be 1 mark. I'll have to look at that again. Let me take a quick look at the assignments. If you had an issue with the way I marked it, send me an email. But I hope I didn't shift numbers. I might have shifted it. Sounds like there's some issues there. Oh, okay. I might have to reissue this. Let me just check. Okay, so I might have done something stupid in my email. Let me check it. Okay, I might have to send you a new email once I figure out what's going on. It sounds like I've done something in error. I'll check it again. All right, so any questions about the corridor? So that's your homework for next time. So we're going to meet again tomorrow. And tomorrow we're going to deal with the widenings on both sides, right? So if I go back to my corridor, right, we look at it. If you can create this, so this is what I want you to do. You should have your horizontal alignment. If there's a problem with it, you have to fix it. You should have your vertical alignment, so you need to design this, right? So draw that with the correct locations for stations and then the correct slopes for each piece. And then you need to draw this, your 20-meter standard right away. And then marry them all together and to create one corridor. And again, right, see how the edge of asphalt on the inside is in the right spot, on the outside, the edge of the gutter line should be here. Right now it's drawn over here. Same thing with the cul-de-sac, right? It looks like it wants to go straight through. It needs to widen and go all the way around and back again. So that's incorrect. So this does not represent, and this does not represent, and neither does the intersection. Okay, so tomorrow I'll show you how to widen the corridor, and I'll show you how to widen the corridor, the elbow, and the cul-de-sac. Okay, but if you can get this much done for homework, it doesn't take long, then you've got the basic model. Then we just have to tweak it a little bit to get the true representation around the widened spots. Well, you're going to have to review each one and try and figure it out. So I didn't specify where you went wrong. I just found that you had a problem, so I took a mark off. If you can't figure it out, then certainly you can send me an email and I'll help figure it out. But the way I would check it is if you isolate this layer, right, list this, make sure it's 12.5, list this one and this one, make sure the radius for these are correct, 3575. Same with these 3, this one should be 15, good. This one should be 36.5. The other thing you want to make sure is that the center of this and this is in the same spot, so make sure you drew it in the right spot. The other thing you want to check here is the center of this is exactly where it should be. So if I offset 4.5 on both sides, and I fill it with a radius of 0, these 2 pieces, that's the center of the arc. So if I click there and I click on these 2 lines, they should move together, right? The center of this arc is exactly where these 2 lines intersect. If you offset this line to draw this, it's wrong. Okay, if I offset to get to the gutter there 5.75, you're going to get a different solution. These two are different. Some people did that. Okay, so don't make that mistake. See that? They're in the wrong spot. And then if you use this fillet against this, then this arc will be in the wrong spot. Okay, so remember, from the standard, the center of this arc is right there. It's not an offset from the outside. And I think a few people did that, so you might want to double check. If you offset this 5.75, which is the dimension in the cross section, right? Let's go back. Right, if you use R1, where is it? 64. Yeah, if you use this one, right? If you use 575 for the boulevard, it's wrong. That's not how it's born. This is what it looks like on the standard 20-meter wide. But on the elbow and the crescent, you have to respect the standard for the elbow and the crescent, right? So there's no offset here. They don't tell you what that dimension is, so don't assume. It tells you where to put the center of that arc is right here, which is 4.5 meters from either opposite street line. They are different, right? I drew this in the right spot. If you offset 5.75, you'll see this is in a different spot. That's a problem. And I would have caught that. I would have seen that on the assignment when I checked it. So if that's a problem. Again, you're going to have to check it. You have to be able to check your own work. So I'm going to leave it up to you to try and figure it out. If you can't figure it out, ask me. I'll walk you through it. Okay. And that's another thing I want you to practice, right? I didn't teach you how to do it, so you had to try yourself. Now I'm telling you how you did, and I'm not pointing out exactly where you went wrong. I expect you to kind of try and figure it out. And what you're about to do, if you didn't get 4 out of 4 on those 2 items, what you're about to do to figure it out is what you should have done before you handed it in to me. You should have double checked it, right? Which is something you're going to have to learn how to do all the time when you're doing this kind of work, right? Like if you're the lead designer, you're the only one checking it. You better do it and then double check everything, right? So that's kind of the process I want you to follow. So again, I've shown you how to do it. Now you got to figure out where you might have went wrong. I've told you there's an issue somewhere. Now you got to narrow it down and fix it. Okay, those are the possible errors, right? Is this offset 425 from center? That's 1 mark. Is this drawn in the right spot? That's 2 marks. Is this drawn in the right spot? That's 3 marks. Did you draw these 2 arcs in the right spot? That's another mark. That's where your 4 marks come from. Okay? So if you got 3 out of 4, one of those is wrong. Which one? Try and figure it out. If you can't, I'll help you with it, right? But try, give it a shot. You have to start to kind of become independent as much as possible. That's part of the training here, right? You can't just always ask somebody. You got to kind of figure it out. So I'm giving you some information, but I'm not walking you all the way to the end. I'm kind of pointing you in a direction where I know there's a problem, and you got to figure out where, right? If you got perfect, then you did it right throughout. If you didn't, you're probably going to learn more than the others, because now you have to go back and see how you did. Yeah, so what I looked at was, once you draw this correctly, right? If you if you drew this correctly, these are the 4 items. If it's in the right spot, then the station at the end should be exactly what I got, because I created these alignments. So I look for this number. If it's short, if it's in the wrong spot, right? If you put it at the center of the circle, then that's the wrong station. It needs to be all the way at the end of the street line. And some people, I think a common error was to take it to the edge of pavement. That's short too. You want to go all the way to the end of the boulevard. Okay. So I know that this station should be a certain value. So I looked for the number I was looking for. For that number to be correct, not only did you draw the geometry right, but you have to put 0 in the right spot. Remember, by default, let me just check this. By default, the beginning station is right at the beginning of the alignment. 0 by default starts there. Right? 0 is actually here. You need to change it, put it to here. So if you drew the geometry in the right spot, the center line in the right spot, and you move 0 to the correct position by alignment properties, you redefine where 0 is supposed to be, which is the intersection of the 2 center lines. You should have 0 in the right spot. You should have the station at the end match what I have, right? So if that's in the correct spot, this will match. You can't stop the alignment at the center line. You can't stop here. It has to go all the way across to the opposite side. So this was another common error. Even though 0 is here, you have some negative chainage. And the reason for that is, when you have the center of the road, you want to make sure that you see the entire half of the existing road. You want to see this half. That's the negative chainage part of the road. Okay. The sidewalk, just redo a couple of things here so I get my thing back. Is this correct? Yeah. The sidewalk from the standard, if you go back to the section 164, the sidewalk is 1 meter in and 1.5 meters wide from their street line. And that's true throughout. That's the only dimension you have. And there's no mention of sidewalk here, and there's no mention of sidewalk here. So I would go with the standard and just take my offset of 1 meter. So offset 1 meter, this piece here, this piece here, this piece here, all the way around. Now, I wouldn't waste your time with 3 pieces the way I have it. What I would do is I'd say polyline edit. I would join, turn this into a polyline, join all the pieces, and then you can offset once and for all the entire subdivision. This and this. I'm just joining all my straight line elements. Okay, so there's my entire, oh, why is this not connected? Should join to here. Doesn't join. This is where the slopping drafting comes in. This. Okay, so it should be 1. I don't know why it's not connecting here. For some reason, yeah, see, there's a gap there. So this one's too long. It should be back here. Polyline edit, join. Okay. So there's my street line throughout the entire subdivision. Right? It goes all the way around. Join this piece too. Okay, so now I would offset 1 meter in, offset 1.5. There's my sidewalk. There's a couple of things that are an exception. When you offset 0.2 to the back of curb in the intersection, extend to the curb, there's where your sidewalk ends. Okay, some people didn't know what to do. They did that. Some people did offset of 1 meter here with a 1.5 meter wide. And then you have a fillet of 0 between these two. Some people drew this for the sidewalk. That doesn't make any sense. It doesn't go anywhere. You want to take it to the asphalt. Right? You want to walk along the sidewalk, and then when you get to the concrete curb and gutter, step down onto the asphalt and cross the street. Same thing here. Extend to the back of curb. And that's why you have to draw the back of curb first, so the sidewalk has somewhere to end. Okay, so that's how I would do the intersection. Here, this is another point that's kind of weird. Yeah, I'll talk about that in a minute. Let me finish the sidewalk discussion. This, strictly speaking, this is exactly what I would do with the sidewalk. There's a couple of options here. You could extend the sidewalk, offset 0.2 to the back of curb. A second, closing. Computer's frozen in there. Okay, so this is what I would have drawn for the sidewalk, right? 1 meter in from the gutter, from the street line, and 1.5 meters wide. There are options here. Here's another option. You could figure out what the offset is here. Offset from here, perpendicular to here, and then just keep that constant all the way around, 1.5. So there's one option for the sidewalk, right? So have these two parallel to the gutter all the way around. Or you could do what I did originally, offset 1 meter from the street line, 1.5 meters from there. So that's another option, this straight piece. And you may have seen in other places, if there's a sidewalk on both sides, you might do this. You might offset 0.2 to the back of curb, right? You have your back of curb, and you would offset to the back of curb these two and have them cross each other. So there's another option. And then in here, this is all concrete, so you could trim this all off. This is all, whoops, this is all concrete. Here, here, and here. So this is all concrete in here. So that's another way of doing it. And depending on how small this triangle is, you might make it all concrete. You might get rid of that altogether. So you might do that. As long as you drew a sidewalk, I gave you 1 mark. Different options, it depends. Okay, so there's no solution for that. This might make sense because there's a sidewalk on the opposite side. So if you want to cross from in the corner from here to there, you might do that. Okay, that's one way of doing it. If you don't want to give an option to cross the way, then you could do one of the other options, right? You could offset the 1 meter from the street line, 1.5 meters wide, and have this as a sidewalk, right? Or you can do the curved version. Right? It's up to you. Or if you want, you can even keep that little piece in here. This piece is part of the boulevard. So there's a few options. I didn't mark this. As long as you did something, I gave you a mark. Okay? So that's how the sidewalk should go. Everywhere else is standard, right? 1 meter in, 1.5 meters wide. There's your typical sidewalk right there. Okay, what other questions do we have here? The pipes, I wasn't too hard on the pipes. What I did with the pipes was I made sure you had sand and storm on the right spot based on the existing, right? So one of these is sand, one of these is storm. So you didn't get to choose which side of center you had your sand and your storm on. So that was one mark. Okay, and then the other thing was if you had a length that was longer than 110 meters, I took a mark off. And everybody had to have the short pipes in here. Remember the two little short pipes coming around here, offset 3 meters. Everybody had to have, two short lengths of sanitary and storm across here. So, should have had 2 maintenance holes here and 2 maintenance holes here. And again, you didn't get to choose which side of center you had your sand and your storm on. I think most people got that right. Yeah, and I think that was it for sand and storm. I'm going to talk more about the sanitary and the storm sewer when we do the actual sewer design. Okay, so whatever you did in the plan view, if you didn't get perfect on it, don't worry about it right now. We got to get this corridor model going. Okay, I'll talk more about your layout for sand and storm later. I had exactly, so no, 110 is allowed. So if you lost a mark, it was probably for something else. Okay, so if you can't figure it out or you're not sure, you can ask me and I'll look at yours specifically. Okay, but don't worry about that. The two main things you need to worry about right now are the highlighted areas, right? The alignment of the road and the edge of pavement or the back curb thing. Okay, so if you have to make those corrections, do that now. And then if you did draw your profile, you may have to project your points from plan to profile again, and you might have to redesign this. If you drew something in green, don't delete it. You can always change it. The water main, was it on the correct side of the road, right? So if let me just see mine. So I'm going to look at the sanitary maintenance hole. I'm just going to make this red for reference, and I'm going to make the existing storm maintenance hole green for reference. Right, even though they're shown as gray. So now I know, oh, there's my, so I'm going to offset 1.5. My storm is on this side, and my sanitary is on the opposite side, 1.5 meters away. All right, so I'm just going to make this, this one, I'm going to just make this red. It should be on the proper layer. I'm just going to make it red for now. And this one should be green. So you don't get to choose which side of your storm and sanitary is on, right? Once you do that, the water main is on the same side of center as the sanitary. Okay, so if you look at the cross section, go back to 164 here, right? Storm on one side, sanitary on the other. The water main is on the same side as the sanitary relative to center. So if the sanitary is on the right side, the water main is on the right side. So then what I do is I look at the curb line, right? So if this is all one, thing, right? If this is all connected, which it might be if you did this drafting clean the way I did, right? I don't want to offset each piece, so it's good practice to connect everything. So if this is your edge of pavement line, so there's my edge of pavement. I'm going to offset by 1 meter, right? Why 1 meter? Because that's what it says to do here, 1 meter. Right? So if you know where your gutter line is, 1 meter into the boulevard is the water main. So I'm going to offset this line 1 meter. That's my water main. And then there's only one, right? So if that's blue, I'm going to explode this. I'm going to extend it to where the water main is on the other side of the road, the existing water main, so that all your utilities should show. So if you go to the storm, the topo T dash water main, That's my water main there. I'm just going to make it cyan so you can see it. All I want you to do is extend it to the water main. That's your water main. Remember, it should be on this side, right? Extend to here. So there's two options. This one's wrong. It's the one on the sanitary side of the street. And then these two, right? These would end here. And this would end here. Right, so the water main is on the same side of center as the sanitary. And you keep that all the way around. Just keep these curves. Don't do anything special here. Do all the way here. And then when you get to here, right, on this side, there's nothing. So there's no water main on this side. And then this is wrong, and this is wrong. So stop there, right? And now you have to do the loop. How do you draw the loop? Again, I drew each one and I compared it to yours. You have to interpret now the water main. We have time? Yeah, we have time. You have to interpret the water main, which is here. So I told you W71. Sorry, where is it? Standard drawings. This one here. Okay. So how do you draw this? So right now, all I drew was this piece here. All right, I have the water main in the standard position. I have to take it straight out under the curb and around, right? So if this dimension is correct, 1.2 from the back of curb, or if you take it inside under the asphalt from the gutter line, you remember the back of curb is 0.2, so if I have the gutter line, it's only 1 meter in. So from here, right, if this is my edge of asphalt, I'm going to explode this. I'm going to offset 1 meter from my gutter line. There's where the water main goes. Right, so from here to here to here, that's where the water main goes. Okay, it says 1.2 from the back of curb, but I know the back of curb to the gutter line. I know from my back of curb to my gutter line is 0.2 meters, 150 plus 50. So from the gutter line, it's 1 meter in to the asphalt. Okay, so that's where these three lines go. Okay, now how do I connect everything? Well, if I extend to here, this line here, right here, if you go to the standard, there's a radius of 5 meters. So I'm going to use a fillet with a radius of 5 between this one and this arc. So there's the 5 meter radius. Right, that radius is this information here. Right, so I take this along, I do a 5 meter fillet, and then I have that 1 meter offset all the way around. Now how do I come back around? Well, you have to find where this is. To find this position, what you need to look at is the hydrant. So see this BC, this point here, BC, that's the last time you have a standard 20 meter right of way, and then it gets wider. So this point here, BC, it could be called EC. That's the beginning of the curve that goes into the cul-de-sac, which is this point right here. Way back here, this point. I'm going to draw a line from this BC to this BC, right? And that should be 20 meters long, right? 20 meters right away. So there's where the widening starts, which is exactly what this tells you. Right here is where the widening starts. The hydrant is exactly at that position. So from there, I'm going to go 1.5 meters to this valve, 4 meters to the T. So from this position, I'm going to offset 5.5. So I'm going to offset 5.5 away from the cul-de-sac. So that's the tie-in point. That's where the T goes. So I want to match this to this. And now how do I bring it around? Well, I still need this under the asphalt by 1.2 or 1 meter in. So another common mistake is to forget to offset the straight piece and just use the curved piece. So I need to do one more offset. And offset 1 meter, the gutter line into here. So this should match. And then I need to fillet these two by a radius of 2 meters. Fillet with a radius of 2. This straight piece with this piece. A common mistake is to fill it with the curve and the straight piece, and that will put it in the wrong spot. That's what it should look like. And that's all I asked you to draw, the center line of the pipe, right? But the position of this is 5 meters away from this point, right? This way, 5 meters. So what I did is I drew it. I inserted my drawing on top of your drawing. And if your lines didn't match exactly my lines, I took a mark off. If the water main was on the wrong side of the road, I took a mark off. Okay? So there's only one solution, but you have to, and this is part of the training, right? When you're done, this is what it's supposed to look like. But nobody teaches you how to draw that. What do you draw first? What do you draw next? That's the part that you're being paid for. That's the part you have to figure out for yourself. So I'm going to give you some opportunities to interpret the standards and then draw the solution. I can check that you drew it correctly, but I have no idea how you got there. That's up to you. And I'm not going to explain it all the time either. You have to try it for yourself. Otherwise, you'll never gain the experience and the confidence you need to do this type of work, right? You always have a standard to go by, and now it's up to you to interpret it. And sometimes what you're trying to do might not have a standard, so you have to draw on previous experience, go to other municipalities and see how they kind of did it and try and do the same. There's a little bit of that next semester, so I'll build on this whole way of treating you next semester. But that's how you draw the water main. Do we need to fix things like sidewalk or what? No. The sidewalk, if there's anything wrong with the sidewalk, you can ignore it. That's the last time we'll talk about the sidewalk. If the water main is wrong, you can ignore that. I would suggest you fix it if you have time, but it's not necessary going forward. So today is the last time I'm going to talk about sidewalks and water mains. Okay. Next semester, we'll spend a lot more time with the water mains and a little bit more with the sidewalks. But for now, I just wanted you to do something. The exercise is not in drawing the sidewalk specifically. The exercise is, can you interpret the standard and draw a solution? That's really what I'm trying to get you to practice. Okay, so don't get lost in the sidewalk specifically. Try and make sure you understand how to read a standard and draw the solution. It doesn't matter what the item is, right? I've just given you some examples of things to try, right? That water main one, that's a cool one. I really like that one. Where do you draw the water main? And there's more to it. The water main over here, this is wrong. This is not going to happen in reality. These radii are too tight for plastic pipe. If you try and bend the pipe to those small radii, it'll break. How do we deal with that? Next semester. Okay, it's beyond the scope of this course right now. Okay, so that's all I want you to do. Okay, so that's it for today. I'm going to double check what I sent out. I think I might have got the text wrong, but I think the actual breakdown of your grade might be correct. But I will double check that. I'll send an announcement. And again, you only need to fix the stuff that's highlighted for right now. Okay, we'll talk more about the sanitary and storm pipes in assignment 4. Not to worry about that now. Okay, so for homework, try and get that corridor built, right? And then we'll discuss how to widen it tomorrow. Yes, I'll be teaching next semester. I'll be teaching your capstone course for the municipal option. You actually get 2 professors. So Professor Moran Neruzzi, he'll teach you 2 hours or 2 periods of lecture for the capstone course, and I'll do 3 periods for the lab part. So all the CAD stuff I'm going to be teaching, all the standards, he'll be handling most of that. So you actually get both of us. So whatever he's teaching you, you guys are taking MPT right now. The stuff he's teaching you in MPT and the stuff I'm teaching you in CDA is the bulk of the things that you need to learn and master for next semester. If you understand the standards he's talking about and you learn these techniques in Civil 3D, next semester should be a lot of fun. You're going to design something. Okay? And the only thing that's new is the data you start with, right? You're going to get a new topo, a new subdivision layout, different standards to use, but the process is going to be very, very familiar. So the harder you work this semester, the more fun it's going to be next. Yes, exactly. Yeah, how Paulo and I work together. Yeah, but it'll be a lot more. We'll be aligned a lot more, Professor Neruzzi and I. It's not quite like highways. In highways, it's almost independent, but they complement one another. In MED, we're working side by side a lot closer than we do in highways. Okay. So that's it for today. Try and figure out where you went wrong if you can, and if you have any questions, you can email me. And I've got office hours, I believe, tomorrow. Let me just check my schedule.